Okay, great. Let's get started. So welcome everyone to the Fireside chat or talk on AI and language. So today we're going to do something a little bit different. I want all of you to go to slide.do and the guest code is CS221. So we're going to try to use this platform for doing Q&A, and also I'm going to have a number of polls throughout the talk. So the first question, if you click here, you'll hopefully see that it's what city are you in right now. And I already got some responses: San Jose, Palo Alto, Stanford, Seattle, College Station, Fort Mill, Cupertino, New York City. So welcome everyone from all over. And if you go, oops, I guess this Zoom thing is in the way. Okay, I guess I can't see that, but anyway, you can go to, there should be a Q&A tab where you can go and type in your question. I'll try to monitor that throughout the hour. Okay. All right, so I want to start by asking you a very simple question. What is the difference between these two cute little kittens and these two kids here? Anyone know the answer? Both can see, smell, taste, move around the environment. Kids are sometimes cute too. What's the main difference? Let's make this interactive. Someone just shout out an answer.
Humans can talk.
Humans can talk. Yes, thank you. That is the main difference. And while animals do have some sorts of communication, especially songbirds and dolphins and honeybees have their waggle dance, none, I think, could boast as such a rich and complex language as the human language. So it's really, I think, language is something that's uniquely human and defines kind of who we are. So before getting into talking about AI and NLP, I want to spend some time just talking about why language is special and hope that we can get a richer appreciation for a language. So if I had one slide to summarize language, this would be it. So this is one of my favorite XKCD comics. Some of you probably have seen it, but I'll just read it anyway because I think it really highlights the right mode. So anyway, I could care less. I think you mean you couldn't care less. Saying that you could care less implies that you care at least some amount. I don't know. We're these unbelievably complex brains drifting in a void, trying to in vain to connect with one another by flinging words out into the darkness. Every choice of phrasing and spelling and tone timing carries countless signals and context and subtext and more, and every listener interprets these signals in their own way. Language isn't a formal system, it's glorified chaos. And you never know for sure what any words will mean to anyone. All you can do is try to get better at guessing how your words affect people so that you have a better chance of finding ones that will make them feel something like what you want them to feel. Everything else is pointless. So I assume you're giving me tips on how you interpret words because you want me to feel less alone. If so, then thank you. That means a lot. But if you're just running my sentences past some mental checklist so you can show off how well you know it, then I could care less. So what do we learn from this? So first, language is social. It's meant for communication, right? I think a lot of us coming more from a kind of data or ML background, I think language is just a body of text, but it's really this dynamic thing that humans invented to communicate with each other. The other thing is that language or talk is cheap. And something about language requires incredible amount of trust between the people so that it actually can function. But interestingly, it can also be used to deceive, which is interesting right now. And it's just kind of miraculous how language allows us to express all these different thoughts, from poetry to math to how to fix a bike and so on. So where did language come from? The short answer is no one really knows. And it's really hard to pinpoint it because, well, writing came around 3000 BC. And before then, it was a long period of spoken language. And spoken language doesn't leave fossils or anything. And there was so much skepticism, kind of controversy around that, it was actually banned. The study of origins of language was banned for about 100 years in Paris. So, but we do just kind of conservatively put an estimate. It started maybe 2.5 million years ago when Homo sapiens first came on the scene to sometime between 100,000 years ago, which is when modern humans really started doing things, which is a huge range. But to put it in perspective, this is a very recent development compared to the history of all of life on Earth. And we know that it served an evolutionary purpose. So if you read *Sapiens*, this book by Yuval Harari, language is perhaps one of the key reasons why Homo sapiens became so dominant, because they allowed you to communicate and coordinate on such massive levels. And for example, detecting when coordinating on a hunt, for example, or communicating about food sources and so on. And interestingly, language allows you to talk about things that aren't here and now. That is probably one of the most powerful things. And in fact, it allows you to talk about things that don't even exist. There's a whole genre called fiction that's about that, and things which are in the abstract. So in contrast, like I said before, our kind of sister fields of computer vision and robotics tap into capabilities that have been around for much longer. Like vision is over 500 million years ago, and language is barely, let's say conservatively, maybe a million or 2 years ago. So just for fun, let me do a poll. Let me actually have to create the poll first. So what language do you speak? Languages do you speak? Let's see, multiple choice, free text. Okay, let's see if this works. I have to disable. Okay, so go to the poll and let you fill that out. So we know that language, there's not one language, there's multiple languages. And furthermore, languages have evolved. So you can draw kind of a giant family tree of languages. And this branch just shows the Indo-European languages, which covers all of Europe, and Iran, and some parts of northern India, which developed like 10,000 years ago. And this branched off into kind of Germanic languages and Romance languages. Germanic went into German and English and so on. And today there's 6,500 languages, many of which are actually going extinct because language, again, is social. So if you don't have anyone to talk to, your language just kind of disappears. And language is changing all the time. English has definitely evolved since Shakespeare, but I think in grade school, you're probably told that they is supposed to be plural, and you shouldn't use, say, they to refer to a singular person. But now it's, especially with kind of this trend toward having gender-neutral pronouns, they is, kind of proudly singular, and Merriam-Webster kind of declared it as the word of the year in 2019. You can think about internet slang and emojis as also kind of a continuation of language into the kind of digital sphere and so on. Okay, so I'm getting a lot of English, Mandarin Chinese, Japanese. So, quite a bit of Python 2, Python 3. Yes, very nice. Okay, so one thing that is, I often get asked is, all these languages, are some more harder or more powerful than another? It's clear that and I think widely accepted that all languages are kind of basically equivalent. But there was kind of this hypothesis around the 20s called the Sapir-Whorf hypothesis that says the structure of language affects speakers' worldviews. And you see this in kind of fiction like George Orwell's 1984, which talks about a new language called Newspeak, which was simplified so that they could make sure people couldn't think to even critique their government. This has been challenged by a universalist school, Chomsky and Pinker, who thinks that language and thoughts are universal and all of the differences are very superficial, governed by a few parameters. And it is true that languages do differ. They are largely the same. Most languages have nouns and verbs that refer. We all are humans living in the same world, but there are some differences. One for an example is that English lacks what is called clusivity, which is the distinction between when you say we, it's ambiguous whether you mean to include the speaker or not to include the speaker. Whereas some languages like Tamil or some Chinese dialects actually have that distinction. Or Mandarin Chinese lacks the distinction between past tense and present tense, but of course has other ways of accommodating for that. So one question, maybe to just have another poll is, let me stop that poll, is do you believe that language shapes thought? Now, I know that these questions are, obviously not binary, but I just wanted you to kind of, get a gut feeling. Are you leaning more towards yes or no on that? And I will activate that poll. So do you kind of abide more by the Sapir-Whorf hypothesis that the structure of language does influence how you think about the world, or do you think that all humans are really the same, and we just happen to learn different languages, and those differences are fairly minor? So can you guys see the numbers?
Yep.
Okay, so we have about 90% Sapir-Whorf, and about 10% no. Okay. So this is a richly, hotly debated topic in linguistics, even to this day. So another fascinating thing about language is that we're not born knowing it. Babies can make sounds, but it takes them a few years to be able to actually acquire language. And importantly, despite what their parents might think, they're not taught from explicit instructions or from teachers. Rather, they're taught where they learn naturally from immersion of language. And by the time they're 5, they're actually fairly kind of have a fluent grasp of the language and speak grammatical sentences and so on. And its language acquisition is very multimodal and grounded. So language accompanies sight and sounds and action and touch and all these things. And it's active. You can't teach a child by just putting it in front of a TV and expecting language acquisition to occur. So, one of the big questions around language acquisition is the nature and nurture debate, which also affects kind of other areas as well. So the big question is language, innate. So Chomsky, who was a famous linguist, in the 50s, he came up with this idea of what he called poverty of the stimulus. And he said that basically sentences that a child hears can't possibly be responsible for the richness of language that's exhibited in actual humans. So he concluded naturally that language must be, a large part of language must be innate. Sorry, I'm trying to delete this poll and add a new one at the same time I'm talking. Okay, so I'll ask you this poll. Do you think language is innate? And if you think about it, he does have a fair point, because we do as children hear so few of the examples, and then we can not nearly enough to really capture all the cases, and we constantly run into new language all the time, and we have to generalize compositionally to longer sentences, to new contexts, and we kind of all land on this kind of same language. So I think he does have a point. On the other hand, he wasn't an experimentalist. He was a kind of a classic armchair linguist who thought deep thoughts about how things should be. And there's also, one could imagine, what about the role of grounding? And maybe that is the part of the experience that really shapes language acquisition. And maybe we are just kind of really malleable and so on. So it seems like everyone's quite divided on this. So 53 yes and 47 no. Okay, that's always fun. So maybe you guys can talk about this with your friends. What I will say, now that, whoa, this is a tight race. What I will say is that, no matter where you're on the spectrum, once you have kids, you really think that there's more innateness than there's not. So now it's equal 50-50. Okay, great. So let's move on. So let's take a look at language itself. And I'm going to introduce some basic concepts. So there's a whole field of linguistics that studies language. And I really encourage you, if you're interested, to take a linguistic class. I think it's one of the most kind of interesting, eye-opening kind of experiences. But I'll just go over some kind of basic things quickly. So here's a sentence. Beethoven was born in Bonn and displays his musical talents at an early age. What's going on in the sentence? The linguists ask, what is the structure of the sentence allows us to kind of understand what it means. So first of all, there's tokenization, which is, the sentence is just a stream of characters, right? And tokenization is a process of converting that into words. Seems very simple, right? But as we'll see later, it's not as simple as it kind of looks. Part of speech tagging is the idea that some words are nouns and other words are verbs, and some of the verbs are past tense versus present tense. Parsing goes a step further and talks about the grammatical relationship between words. For example, displayed has a subject and an object. And the subject is, in this case, what is the subject? Anyone? I know there are English speakers in the audience. Is it Bonn? Okay, I think maybe it's Beethoven, right? Okay, so even though Beethoven is very far away from displayed, it's nonetheless grammatically very close to displayed. And this is a property of language. Language has to be linearized, so not everything can be close to each other. Co-reference resolution, or anaphora, corresponds to the fact that some words are pointers to other words or concepts. So his refers to Beethoven. Named entity recognition is the task of identifying which entities, now usually proper nouns, are per people or locations or organizations. So what is a word? So let's go down into a word. So okay, here's a word, light. So it seems like a word is pretty straightforward, at least in English. But the problem is that the meaning of unit, what is kind of conceptually should be a word, actually goes beyond a word. So light bulb is kind of a unit. It's not, light doesn't really capture the full meaning of that word. Sometimes the meaning unit is within a word. For example, lightning isn't just a blob. It consists of light and then the suffix -ing, which kind of turns it into a verb gerund construction. There's also cases where words have multiple meanings, usually called word senses. So in all of these sentences, you can see that light actually has a different meaning, and we figure it out based on context. On the conversely, some meanings have multiple words that refer to essentially the same meaning. That's synonymy. This also happens with sentences, which is called paraphrase. Multiple sentences could get at the same meaning. Just a huge caveat is that there's no true equivalences between any two words or sentences. There's always different subtleties in meaning, so you can think of it more as a kind of distance metric. There's also notions of relations between words like hyponymy, which is a relations, and meronymy, which is has a relations. And this allows you to do entailment, which is whether a sentence logically implies a second sentence. Entailment, you can kind of think about the the 3SAT of language. It's kind of the problem that embodies a lot of different tasks. If you could solve entailment, you can do question answering, you can do sentiment classification, and so on. Are there? I haven't been monitoring the QA. I don't know. I don't think there's any questions. If you have a question, maybe just holler. So this is all about lexical semantics, the meaning of words. Then we talk about compositional semantics. So this compositional semantics is kind of rich tradition that goes back to kind of logic. So this is Frege, who was a logician at the turn of the 20th century. And there's two ideas, model theory and compositionality, which I'll explain. So the first is that sentences these are just symbols, right? It's a convention that we say block 2 is blue. And what the sentence means has to be associated with what is in the world. So there's a world in which the block 2 is actually blue. And so this is kind of important distinction, which we kind of, in NLP, kind of gloss over, or you probably we don't even think of it because of, language is so, natural. The second one is compositionality, which is that the meaning of a whole is the meaning of the parts. So compositionality is the key thing that allows us to build more complex meanings out of smaller units. And this is probably the reason why we can generalize to all sorts of new contexts, because we've learned the meaning of the words and we know how they combine together, and that's how we can generate, we can interpret the new sentences in new contexts. Quantifiers, I think, are really interesting. So every is a word that says that, well, it's hard to explain language without explaining in terms of language. So every means every. Hopefully these pictures tell you what's going on. And some is a kind of an existential quantifier. There's also a quantifier scope ambiguity, which means that if you have every non-blue block is next to some blue block, that could mean that every blue block is next to some blue block, which is, that was very tautological, which could be different, or that there exists some blue block that's actually next to every non-blue block. So language is ambiguous. So modality involve words like must and can, and this has to do with possible worlds. In all these possible worlds, block 2 is blue, but block 1 is only is red in one of the worlds. Beliefs are interesting. So we know that Clark Kent is the same person as Superman, but and naively you might think that we can just substitute these two in all contexts because they're equivalent. But Lewis believes that Superman is a hero is not the same as Lewis believes that Clark Kent is a hero. And this has to do with the fact that this believes sets up a kind of opaque context which you can't just do substitution. There's much more to be said about this if you study linguistics. I just want to give you a flavor for how language can be kind of quite subtle. Here's some other examples of pragmatics. So pragmatics, the conversational implicature is this phenomenon where there is a sentence that you say, but there's actually additional meaning beyond that sentence. So if two people are talking and A says, "What on earth happened to the roast beef?" and B says, "The dog is looking very happy." Sure, the dog is looking very happy. That's a sentence. But really, the implicature is the dog ate the roast beef. Presupposition is actually kind of very subtle but different, is the background assumption that's independent of the truth of a sentence. So if I say, "I have stopped eating meat," what's the presupposition? That means I was once eating meat. Okay, so regardless of whether I have stopped eating meat, or if I said I didn't stop eating meat, that still presupposes I was once eating meat. So presuppositions are these very slippery and insidious things that people use to convey, to convince other people of things that without them knowing. So it's really useful to know what a presupposition is, because if someone tries to presuppose something on you, then at least you'll have the language to detect what it is. And it's precisely insidious because it's in the background. So you're focusing on, did I stop eating meat, without realizing that you just got a presupposition that you might not agree with laid on you. Okay, so Paul Grice, who's this philosopher, established language as a kind of cooperative game between a speaker and a listener. And it is that the dynamics of the game is what gives rise to these things like conversational implicature and presupposition. Right? This goes back to the XKCD comment. It's really a game between speakers and listeners who are trying to communicate and agree on something, and the conventions and what language means in all these contexts is really kind of context dependent and fluid. Just a few other ideas. Ambiguity, vagueness, and uncertainty. So let me try to explain what each of these means and how it's different. So ambiguity means that a sentence has more than one possible but precise interpretation. So here's some headlines, and let me know what you think of them. Okay, so stolen painting found by tree. Okay, so what does that mean? How about Iraqi head seeks arms? Or local high school dropouts cut in half? Juvenile court to try shooting defendant. Kids makes nutritious snacks. Ban on new dancing on governor's desk. And you can see, if you're kind of smiling a little bit, that these headlines are funny because they have maybe a serious meaning and then a meaning which is totally ridiculous, but is nonetheless kind of technically ambiguous. Vagueness is where a sentence is not has one interpretation, but it does not specify the full information. So if I said I had a late lunch, there's no ambiguity there. It's just that I didn't tell you what time I ate lunch. Maybe it was 1 o'clock or 2 o'clock or something. Uncertainty is another form of not knowing something, and it's due to having an imperfect model. So if, say, the witness was being contumacious, some of you probably know what that means, so you're not uncertain, but some of you probably don't. And you have this uncertainty, which is not a property of the sentence, but of your the speaker's ability to understand natural language. So all of these things are useful to think about differently, although often they get conflated, especially in kind of more model-free methods. So I will say that there is another form of style of linguistics called distributional semantics, which actually goes back to the 50s as well. And I'll give you the basic idea. So if I give you these sentences, the new design has blank lines. Let's try to keep the kitchen blank. I forgot to blank out the cabinet. So what does blank mean? Or what word goes there? Someone say the answer.
The answer's in chat.
Oh, okay. I didn't know there was a... This is in the Zoom chat?
Yep.
Okay. Let's see. I think I lost my... Okay, chat. Okay, there we go. Ah, okay, there are answers. Okay, clean. Great. Okay, got it. Okay, so the idea about distributional semantics is I didn't have to tell you what the word means. The meaning of the word is characterized by the contexts in which it appears. So this is the idea of the distributional hypothesis. Semantically similar words occur in similar contexts, or more eloquently said by Firth, you shall know a word by the company it keeps. So this is another way of thinking about semantics. And actually the one that has really been picked up because it's so synergistic with modern kind of statistical techniques. So just going to summarize there's two ways of thinking about semantics or meaning of sentences. One is compositional semantics, where it's more top-down and you model first. So you think about how language works. You try to think about parse trees or semantic forms, and you can capture a lot that way. We went through a lot of examples where language, you can feel kind of language does obey certain types of structures. On the other hand, you can think about distributional semantics, which is a bottom-up, data-first approach, and generally associated with vector spaces, where you think about just words as meaning and not really trying to nail down what meaning is, but just associated with the set of contexts in which appears. So let me do another poll. And let me hold on. I need to create this question. And ask, what do you think is the best way to achieve natural language understanding? So is it compositional semantics or distributional semantics? Okay, so go to Slido, and I'm curious what you think. Okay, so it would have been interesting to go back maybe 10 years and ask this question, because I think the answers would have been quite different. And I'll talk a little bit more about that in a bit. So it looks like it's about 30% compositional and 70%, maybe three quarters. So most of you think that distributional semantics is the way to go, which is maybe concordant with what is happening in the world right now. Okay, so why don't I take a few minutes right now. I went through a lot of material, and maybe I'll just ask if there are any questions to discuss. No questions? Someone has to have a question. So one question is context information. It's never spelled out, but the meaning depends on who is speaking at where. Yeah, so I've been kind of deliberately vague about what context is. Traditionally, it's a linguistic context, which is the words next to a sentence, but you could imagine that it could be very much generalized to context of the speaker in the think multimodal, what's going on in the world, who is speaking, to whom the person is speaking, and all of that rich contextual information. It definitely is useful for understanding the meaning of that word. So in the beginning, you said that humans have the highest level of communication. How likely is it that actually some animal has much higher level of communication, but we're not smart enough to understand it? Yeah, that's an interesting question. It's almost a little bit of a philosophical question because it is, in theory possible that some animal has, brilliant system of communication, and we just didn't, measure it, properly. People have been surprised by how sophisticated certain animals are able to, communicate, like, dolphins or elephants or even, bees. Often people separate the line between having recursion or language that's able to express kind of compositional thoughts versus ones which are maybe very contextual and nuanced, but don't have that kind of level of abstraction. And so, according to that, I think we're pretty sure that humans are the ones that have the most amount of abstraction. But then again, I guess this is also a very human-centric way of defining, what highest level of communication means, because maybe some other creatures have more, contextual and more nuanced than human language. Elephants communicate in below 20 hertz infrasound. Okay, and Hitchhiker Guide, thanks. That's a good one. How about plants communication can be chemical, color, temperature, even touch? Yeah, so there's a lot of other, and I guess in general, communication is not the same thing as language. Yeah, so I'm using language very narrowly here to mean kind of human language and what we know to be human language. Of course, even humans communicate in other ways like gestures and so on. Okay, great. Let me move on. Thanks for the questions. So what I want to do next is to talk about building language understanding systems and what has happened over the last maybe 60 years now that we have maybe a greater appreciation of what language is. So we've kind of seen this slide before. It's the Turing Test. Alan Turing in 1950 asked a philosophical question, devised the Turing Test to test whether a computer could be, or a machine could be intelligent by seeing if it could talk to a human and convince the human that it was actually a person. This is one of the dialogues that they have from his paper. You can read it. What I want to emphasize here is that Turing was not interested in language and wasn't trying to design a language understanding test. He was trying to design a test of intelligence, and language was just the means to convince someone or to kind of verify that there was something up there. And so I think this is kind of very interesting from an AI perspective, because language does seem like it has a unique capability of being able to even, in order to have intelligence, you need to be able to essentially show it in some way. And you can think all the deep thoughts in your head, but if you don't have a way of kind of externalizing it, then, well, it's like the, if a tree falls in the forest, doesn't make a sound kind of, setting. Language has turned out to be a very useful way of kind of probing for understanding. One of the early systems I want to highlight is Eliza. So Joseph Weizenbaum, when he was at MIT, developed this system called Eliza, which was really meant to be a parody of a psychotherapist. So the system would, you would lie on a couch and you would talk to the system, and some dialogues would go like this. So Eliza would say, is something troubling you? Men are all alike. What's the connection, do you suppose? They're always bugging me about something or other. Can you think of a specific example? Well, my boyfriend made me to come here. Is it important to you that your boyfriend made you come here? This is, I'm so depressed, and so on. So what was interesting about the system is that the system itself is very simple. This is 1960, so there's not that much kind of going on in terms of complexity. It was based on rules and matching. So you can imagine a rule that says if the word alike shows, then you ask what is the connection, or if you say always, then you say, Eliza says, can you think of an example, specific example, and so on. So it was very simple, but what Joseph Weizenbaum found out, which was really surprising, is that the people he showed this to actually started getting emotionally attached. And there was one incident where Weizenbaum's secretary actually asked Joseph to leave the room so that the secretary could have a real conversation with Eliza. So this is kind of in the 60s. I think it was very perhaps I guess telling of maybe what is to come. Later I'll talk about GPT-3, which is obviously a much more realistic version of this, but you could think definitely about some of the consequences of that technology. Incidentally, Weizenbaum later in his career became very pessimistic and actually very negative and critical about technology, maybe because he had this epiphany that, well, what we're building is actually maybe not so good after all. So this is one of my kind of favorite natural language systems. It's built by Terry Winograd, was also at MIT, but he moved to Stanford where he became a HCI faculty for a number of years. It's called Churlu, and the idea is that you have a person who is able to conduct a dialogue about a block's world environment. So pick up a red block, okay, grasp the pyramid. This computer can say when it doesn't understand things, find a block which is taller than one you're holding and put it into the box. So it's fairly complicated, and the computer can kind of reason and do a NAFRA, a co-reference resolution, and ask for clarifications and so on. What I think is remarkable about this system is that it was an end-to-end system. Included a parser, can do semantic interpretation, dialogue, planning. It wasn't just a language system. In fact, it was more framed as an AI system that could allow a robot to kind of do things in the world. So this was, in some sense, kind of the real super ambitious project for its time. However, while Churlu worked really well in the limited domain, Terry Winograd later wrote this paragraph, which is interesting. Said a number of people suggested to me that this is a dead end in AI programming. Complex interactions between the components made it just really hard to understand what was going on. So eventually, Terry couldn't even build and extend the program because it was just too hard to keep in his head. So this is interesting because as we know, language understanding didn't really get solved despite these kind of narrow successes. And the history of NLP mirrors quite closely the history of AI in general. Remember in the first lecture I talked about how AI was filled with more kind of these logical-based methods, which didn't quite scale. What's interesting is that at that time in AI in general, there were people working on neural networks, although the vast minority of people. But in language, it was perhaps even less so, because I think language is actually a discrete communication system, and there was kind of a rich body of work on linguistics, and NLP and linguistics kind of co-evolved in certain ways that made it kind of very natural to embrace the kind of all the logical structure that was embodied in language. But I think people realized that there was cracks that were showing at the seams even in the 70s, but especially the late 80s. And in 1990, it was a time for a new set of methods to come onto the scene. So this actually started a bit earlier from speech recognition, because speech and language are closely related, and speech is definitely something that is the bridge between the continuous kind of noisy world where you want to be doing kind of more pattern recognition type things and the kind of logical world. So HMMs, hidden Markov models, were developed for speech in the 70s and 80s, and finally in 1990 there was this kind of famous paper from IBM research, colloquially called the IBM models for machine translation. They developed a probabilistic model that could translate between two languages. And before then, translation was completely kind of logical and grammar and rule based, and this was a radical way of thinking about it. This is actually incidentally based on a lot of the Bayesian networks or that we'll see later in the course. So for a lot of the 90s, a lot of these what are called generative models, think about them extensions of Bayesian networks, really kind of dominated NLP. Near about 2000, there were people started turning to discriminative models, aka classification, linear classification, and there was another famous paper called which introduced conditional random fields, which marries the structure that was so inherent in language with basically linear classification. So this was used to do things such as named entity recognition, where you would mark up words as names of people or companies and so on. And so instead of predicting just one Y from X, you predict a bunch of Ys from X, where Ys are the labels of all the words. So this technology was actually quite influential in NLP, but also more broadly in computer vision, where for much of the 2000s, people were invested in having, this was the kind of main way people tackled kind of structured tasks. Another thing I'll mention is latent Dirichlet allocation, which also came from models of language. And here the emphasis on unsupervised learning, where you point LDA at a text and it can discover topics in the text. So here's a text where it can discover things like, oh, some words are about budget, some words about children, and some words about arts in kind of unsupervised way. And this led to a whole kind of cottage industry of topic modeling papers, and LDA continues to be something that is commonly used in in practice. What I will say is that a lot of these developments, it's interesting to kind of think about how they were developed by someone trying to address a problem in natural language processing, and it led to a more general technology that then was applied in all sorts of different areas like computer vision and genomics and so on. Okay, so now 2000s we're ending, and we know that at the end of the 2000s, deep learning really started gaining momentum. It wasn't, ImageNet was 2009, so it wasn't like a huge yet, but there was definitely kind of rumblings. And it's interesting how kind of culturally how the NLP community kind of reacted. At the time, NLP and vision were both all very kind of skeptical. And if you think about where NLP had been, a lot of people still view language as structure heavy, and language has a lot of latent structure, and no way that this mess of neurons could actually do anything with this kind of intricate structure. And you can think about a lot of the work in the 2000s was really a marrying of this structure with kind of statistical methods. So it was, you can think about as putting probabilistic choices on kind of this very rich structured discrete backbone, right? So in some ways, this is kind of a reconciliation of the compositional semantics with the distributional semantics. You have it both. But still, I think it was still largely based on kind of traditional kind of linguistic thinking. So then I remember there was this 2011 workshop at Neurops. I was at it, and there was some. So Neurops is the machine learning conference. So there were a bunch of machine learning people who were using vector-based models to argue that this covers semantics. And then you have Ray Mooney, who is much more of a logic, old school AI at the time kind of person. And a heated argument kind of broke out. And he is famous for saying, you can't cram the meaning of a whole sentence into a single vector. Okay, so that was captured the attitude, at the time. And then things kind of started changing. I think the first kind of maybe move was word to vec, which was this way of taking lots of text and embedding words so that each embedding was characterizing the context of that word. So actually, word representations had been around since the 90s, but it was somehow this word to vec came at the right time that really caused people to pay attention. And I think one thing that they noticed, which gathered a lot of attention, was the fact that you could do analogies. For example, if you embed things in a vector space, you see that country and capitals are related by a consistent relationship with some asterisks. There was a recent paper from last year which I'll just highlight because I thought it was really interesting. 6 years later, and they used a kind of the simplest method, but it was they ran this word to vec just on about 3 million abstracts of material science papers, just strings, and they were able to discover certain types of patterns by looking at the vector spaces and actually predict certain types of compounds as having certain kind of material properties, like being thermoelectric. So this is kind of an interesting view of how something that's so kind of dead simple and knows nothing about chemistry and only knows about word co-occurrences can actually generate some interesting insights. So word to vec wasn't deep learning in the sense that it was only, I guess, one layer. So it was kind of shallow learning. And I think 2014 was when the deep learning community really kind of, I don't know, in some sense, vindicated itself in the NLP community. So there was this sequence-to-sequence learning paper from Google in 2014, where they did machine translation. And the way they did machine translation was by taking a sentence and running a LSTM. If you don't know what it is, it's fine. It's just some black box that embeds the sentence into a single vector, and then using that vector, it spits out a new sentence. So if you watch the module on differential programming, it'll give you a better idea of what I'm talking about. So this was really cramming the meaning of a sentence into a vector, like literally. And at that time, the results were kind of okay, but it was enough of a proof of concept and surprising enough that later extensions of this really transformed into actually usable technology. So it's interesting if you look at the progression from rule-based machine translation, where there's no machine learning, to statistical machine translation, where there's still still data-driven, but based on more or less kind of some sort of structure of language, to the neural world where there's really even less structure, and things have kind of gotten better. There's a researcher called Fred Jelinek who's famously quoted as saying, every time I fire a linguist, my accuracy goes up. I'm not sure he said those exact words, but that's at least kind of an urban legend. One other note I'll make is that machine translation seems to be the task, at least in NLP, but maybe more broadly, that has really pushed the limits of kind of technologies. And I think it was really the driver that got seek-to-seek technology kind of going. So in 2016, Google kind of completely transformed their machine translation system. And instead of having multiple systems, one for every pair, so you have like n squared pairs, you actually have one system that can do translations between any pair of languages, which was really kind of mind-blowing at the time, and still kind of I think kind of impressive. I'll mention, I think I mentioned some of these things already, but I think it's worth highlighting that these statistical methods do have a lot of biases in them. So if you translate these sentences, you get genders appearing which are correlated with certain types of professions. this is even more extreme. So if you take a rare language where there's not much data and you pump in something that's just kind of garbage, you get some really disturbing translations coming out. This was from a few years ago, so they might have fixed this, but nonetheless, it turns out that you can cram a lot into a vector, but there's some really weird stuff in there. So then maybe this is a good time to pause if there's any questions before the next wave of slides.
There are some questions on Slido, Percy.
Oh, okay. Sure. I guess I started looking at Zoom chat. Okay, so questions. Oh, whoa. Okay, yes, I'll cover GPT-3. How about body language? So I think I mentioned that gestures are typically not studied in NLP, but they're definitely fair game for communication. And there's, I think, an interesting kind of subfield of NLP, which has to do with grounding and how people use language in the world, which it's natural to consider gestures. Let's see. Can we build a common electric language with precise meaning so all languages can reference based on it? So this has been tried. So people have, there was a language called Loglan, which was developed to remove all ambiguity, from language. So it would be, precise and everyone would know what you mean. Personally, I think it was a kind of a little bit of a fool's errand because I think that ambiguity is exactly what allows language to be so efficient. So the meaning of a sentence is a function of not only the words but also of the context. So if the context already makes some things kind of obvious, then you don't really need to say it. And also it's just not, language you have to take into account the ease of acquisition, and it's much easier to kind of almost by construction to learn the languages that we've evolved to learn, and something that's designed is generally not going to be super productive. So NOU is a combination of plausibility and fluency. So what is, I guess, natural language understanding is something I haven't quite defined because I think there's no accepted, definition of it. You can think about it as demonstrating a proficiency on a number of, tasks such as question answering or translation. Or I guess if you think about generation, you have to think about plausibility and fluency, but also, truthfulness. Why did you choose to do research in NLP as opposed to other areas? How would you think about, sorry, there's this icon in the way, what you wanted to study do in the future? Sorry, Slido, I don't know why Slido has this icon that makes me hard to read this. So I guess how do I choose to do research in NLP? I guess this is a very much, a personal thing. So I don't think my answer is, necessarily good for everyone. But I think just the idea of what you can do with language just seems so kind of powerful to me. Like I said, it's one of these things that is so kind of uniquely human. And also I think it seems like a window to understanding, kind of cognition, because it's a way to do the I/O from in and out of brains, I suppose. Is there research on how to incorporate real-time changes in language, the constant emergence of new words and phrases? Yes, so there is a lot of interesting work studying language change over time. There's historical linguistics, which talks about bigger scale changes of Latin to Spanish and French and so on. But there's also interesting opportunity to do it on the web because internet language changes very very quickly. There's always new words that come up, and also on I guess on Twitter things are you can geotag things so that you can actually witness the kind of how language spreads over time. So yeah, there is an active area of thinking about language change. Not just new words, but also the new words changing in meaning. Like the word awful used to mean to kind of, the word awesome, I think used to mean something more like awful, but now it changed, kind of flipped in sentiment from negative to positive. Cool, so maybe I will move on. Thanks for the questions. Okay, so up until this point, so 2014 is when kind of deep learning really started gaining momentum. And from 2014 to 18, it was really kind of neuralizing everything you have. Parsers, co-reference resolution systems, named entity recognition systems, everything kind of under the sun. And numbers went up. Things did get better because the models were just more powerful than what existed previously. I think a big turning point came in 2018. So there's this paper called Deep Contextualized Word Embeddings, maybe better known as ELMO. And the idea behind ELMO can be summarized as follows. So imagine you're trying to do question answering. So, our group, we actually spent quite a bit of work creating the squad question answering data set with 100,000 examples. So it was a lot of work to get that. But in some sense, 100,000 is really, really small compared to the massive amounts of text on the web. And so the idea behind pre-training is that you train a language model to predict the next word given the previous context. And so this is called, I guess, self-supervision. You just make up a task which is called predict the next word given previous words, and then you learn embeddings, and then you use those embeddings to drive some downstream task where you have much fewer labeled examples. And the result was that across the board, all across a number of different benchmarks, the accuracies went up by a few points. So I guess it's maybe hard to really appreciate what like 3 points means, but it was, think about these systems were already hard to improve, and 1 point gain was very good, and this is like substantial gain across a wide variety of tasks. So this got a lot of NLP people really excited. Later that year, a BERT came out from Google, and again, across which is, I'm not going to go into the details. Actually, if you watch the differentiable programming lecture, I do explain a bit more about what BERT is doing. But think about it again as it's a mass language model, which is kind of like predict a word given its context. And this was more or less just scaled up and engineered properly. And this again yielded huge gains over previous methods. So this really, I think, changed the game in NLP from having a kind of specific architectures to do different tasks to a world where you have one architecture that does multiple tasks. So I guess I didn't mention that BERT is now used to essentially power all the, or BERT or plus friends, some Muppet is used to power downstream NLP tasks like co-reference resolution or semantic parsing and so on. So it's really kind of brings us one step closer to having kind of a unified representation that, or unified one model that can kind of rule them all in a sense. So going back to reading comprehension, one thing that is remarkable is that if you look at the leaderboard and the accuracies, they're way above human level performance. So these systems look like they're getting superhuman performance. But one thing that we did a few years ago was to really probe into whether these systems actually understood language. So here's a paragraph and a sentence. The number of new Huguenot colonists declined after what year? And BERT correctly answers 1700, which is right here. But if you add a distracting sentence, which looks like it answers the question, but it doesn't, then BERT will get distracted and answer the wrong thing. And quantitatively, all the systems just fall by quite a bit when added this with this distracting sentence, whereas humans obviously don't get fooled by that as much. So it's one thing to kind of keep in mind is that while models have gotten impressive results on benchmarks, there's still these blind spots that means that solving a benchmark is not the same as solving the actual underlying task, which can be misleading if you read headlines where computers can read better than humans, where that's just not true. Computers do squad better than humans. That is true. Okay, and what's a little bit more maybe worrying is that these models can be easy to break, but we don't actually know how to fix them, except for by training larger models and hoping that they break less. Okay, any questions before I talk about GPT-3, because that's going to be the last topic. Okay, so is naming algorithms for cartoon TV characters a thing or just a coincidence for the two instances? I would say, I would gather that it's very not a coincidence because you also had Ernie that came out afterwards and Big Bird, and it's just, clearly people are going along with the theme. There's another cast of characters, Bart and Marge are other, I guess they're not Muppets, but they're other from The Simpsons, and that is another line that Facebook has been pursuing. Is there any work ongoing to improve comprehension, reading between the lines understanding? It's actually interesting because these models, large models, are so contextual and leverage so much kind of external world knowledge about text that they're almost kind of reading too much between the lines. They're making inferences and making assumptions, which is what leads to all these biases in the models, because it's not stated in the text. They're just learning from associations. Okay, let me move on. So to get to the final thing. So 2020, so in May, OpenAI releases GPT-3. I'm skipping a bunch of other models like GPT and GPT-2, which is in the interest of time. And this was essentially a big language model. I mean, big is an understatement. It's a ginormous language model trained on Common Crawl, which is our best kind of approximation of the internet, so to speak, and has 175 billion parameters, whereas BERT had maybe like 300 million parameters or so. So this is much, much, much larger. So the interesting thing about GPT-3 is this ability to do what they call in-context learning. So traditionally, if you use BERT, what you would do is you have a model, you show an example, and then you perform an update, and you show another example, and you perform an update, and so on. And this is called fine-tuning a language model. But GPT-3 showed that that was actually not necessary to get some interesting performance. So you could actually do zero-shot training. So you could say translate English to French, and you say cheese, and then you give the prompt, and then it will actually do something reasonable. Or you give one example or a few examples, and notice that this is not training data in the conventional sense where you optimize a loss. This is actually the input into the language model. So language model, all it does is that you give it a string and you ask it to predict next string, right? So this is encoding a task actually in natural language, which is kind of a very different way of thinking about learning. Let's see, do I have enough time? Maybe I'll, so OpenAI has this playground. Let me just show you a little bit. So there's many things you can do. You can, so this is a prompt. And I'm gonna say, how can I help you today? Can you tell me the difference between Sarsa and Q-learning? I actually don't know whether this will work. Okay, so sure. Policy inspired by Q-learning. Okay, so this doesn't really answer the question, but that was nice, but that didn't answer the question. Yeah, so how about something else? Who founded Microsoft? Okay, so this is also a lie, but so you can kind of see that it generates fluent English, but it sometimes doesn't have the best tendency to tell the truth. This is another example. So again, this is a prompt, and let me dig this up. So this is kind of from the course syllabus. Oops. So this is some complicated expression, and then this is again what you feed into GPT-3, and it says artificial intelligence is the magic that makes computer do things they're not supposed to do, like talking to their cars. Interesting. Okay, so it's kind of well, you can judge for yourself what to make of this. Anyway, you can. If you have access, you can burn quite a bit of time playing with this. Another example I'll show is you can train it on CS221 quizzes. So you train it on quiz 1 question and answers, and you see how well it does on quiz 2. So here are prompts so what is bold is given to the algorithm. So this should be familiar from quiz 1. And then you ask it, which of the following are examples of regression? And it answers A, C, and D, which is wrong. But then it offers an explanation of this, which is kind of starts off on target, and then it kind of examples of supervised regression: house price estimation, which is actually pretty good, spam detection, which contradicts what it answered, and this unsupervised regression, I don't know if it's a thing. So you can kind of get a sense that GPT-3 is really good at generating text, which if I didn't tell you this was fake, you probably read it and say, but you have to actually look pretty closely now to know that something is up. Okay, there are actually, so I'm trying to give you maybe a more balanced view of GPT-3. I think if you go on the internet and look at all the Twitter, you'll just be completely blown away by all the awesome things people are building out there. But I want to kind of balance it out with some things which are like, yeah, maybe it's not doing everything. But several other things to mention. Now that gender bias, I think, is very hot on people's minds in NLP, they have an entire section in the paper that calls out that, yes, not surprisingly, GPT-3 has gender bias. I mentioned before that there was actually someone who used GPT-3 to generate a blog post, and this ended up #1 on Hacker News for a while. And there's even papers coming out that says that GPT-3 can, primed with extremist context, can generate more extremist content, which is, again, perhaps not surprising given that this was trained on the internet, and the internet has many things, lovely things in it. So some kind of things to think about, I think. So one clear question here is, can we make GPT-3 more unbiased and less toxic? Certainly out of the box, this is just kind of a wild tool that's kind of like you should not be using GPT-3 directly to generate things that to show people. Another question is what are the societal impacts of using text automatic generation, which is kind of related, even if it's not generating unbiased things, but especially if it's generating unbiased things. The obvious worry is that fake news is already a problem, and this is just a massive amplifier for producing large amounts of credible sounding text, which is just swamps out anything else anyone wants to say. So that's potentially a pretty dangerous world. On the kind of more scientific side, I think there's still the outstanding question of can we achieve language understanding without a model of the world or without world experience. So GPT-3 is kind of only trained on text. And furthermore, it has it's just a large transformer model, which has no internal structure. And one question is, can it be said to understand language, or does it need the grounding and experience? So if there were more time, I would actually do a poll and get people to discuss this, because I think it's actually not obvious what the answer is. Maybe I'll end with final remarks, and then I'll take questions. So one thing I want to just, starting at the top, I want to highlight that language is this incredibly rich, complex communication system, quote unquote, from XKCD, glorious chaos. But which is, I think, fascinating to study. At the same time, there's a lot of regularity and structure. There has to be, because I think otherwise we wouldn't be able to productively coordinate and use language as systematically as we have been able to. Current models kind of ignore it, which is but it's also unclear how to incorporate this information in a way that kind of matters. As you can see, the field is moving at an incredible pace, right? GPT-3 was on 2020. BERT was only 2 years ago. Seek-to-Seek was 6 years ago, and only in the last 6 years, NLP has been completely transformed. I would say even in the last 2 years, it's been completely transformed. So it's interesting what will happen in the next year, and I think there's even more, urgency to kind of understand what these models are doing and make sure that the technology is kind of directed in the right way. And then, of course, there's a lot more to be said and learned from this. There are wonderful classes at Stanford that you can take, 124, 224s, to learn more about NLP. So with that, I will take any questions. Let's see. Okay, is voice language a better source than text language? So this is kind of spoken audio. Depends what you mean by better. So voice does contain prosodic cues, which contain more information than what's just in the text. Unfortunately, there's not that much of it compared to all the text that's on the web. I think a lot of the issues of language understanding can be somewhat factored out from speech. Often people convert spoken language into written language, and then you could take it from there. Although there's definitely structure in speech as well. How do you feel understanding multiple languages is a plus of research? How do you feel understanding of multiple languages is a plus of research in NLP? So a lot of research in NLP is very English-centric, which is I think a potential problem if you think about fairness, right? I think many rare languages, low resources languages, as they're called, don't enjoy such high accuracies, and those are probably the people who kind of need it the most. So there is a community of people in NLP who are very much interested in how to design more efficient learning algorithms that help low resource languages. Finally, how has the study of NLP helped linguistics grow as a field? So this is a really interesting question. Unfortunately, I won't have time to really do it justice. Chris Potts is a linguist at Stanford and has lots of insightful opinions about this. Linguistics is interesting because it was, for much of its history, it was so dominated by kind of formal grammars and semantics, starting from Chomsky. In some ways, that his era led to this kind of whole field being dominated by a certain kind of way of thinking. And it's almost that some of these other perspectives hasn't really had a chance to breathe. I think this is, and a lot of this formal semantics is still very much kind of in the logical tradition where you have sentences which are, you look at carefully and you try to intuit what might be going on. It's a very different approach than just looking at a broad corpus and trying to make sense of what's there. So, but this is starting to change a bit. I think at least people are thinking about how these types of models that we're developing in machine learning could be useful. I think that, unfortunately, it's a hard ask because in some ways these deep learning models don't give you much more than existence proof of certain types of data leading to certain types of behavior, and it doesn't really give you necessarily insight into language itself, because interpretability is kind of a missing component. But I think this is a really great question, and interesting to ask, like, how these models can actually help us understand language better, not help a computer exhibit better language understanding. Can we alter and add to the objective function of modern models that makes them more logical and coherent? Yeah, so this is kind of a natural direction that a lot of people are thinking about. So why can't you have both? You can have the richness of modern neural models plus some logical, and there's been a bunch of work that tries to fuse the two together. Personally, I feel like this is far from being solved by just kind of simple combination, because I think there's something maybe deeper about how things should be kind of structured. Like you can add a regularizer that makes BERT kind of be more consistent, or GPT-3 that makes these more consistent. But I think the problem is that why are we using these models in the first place is that they can't be captured by logical regularities, and many of the advantages that we're getting from them are in places where logic kind of fails to deliver. So in those areas, I think we don't have much of an option. We don't have the option of like slapping on a logical regularizer, because otherwise we would have just built a logical thing. How far is real-time spoken communication in multiple languages? So this is like simultaneous translation. So if I am on Skype and I speak in English and it comes out in Japanese or something, this is actually, I would say that this is, not mature technology by any means right now, but it's coming. And I think there's been work, first of all, speech recognition, I think is, getting really, really good. Then the other main challenges in machine translation, what makes real-time difficult is that, word order in languages differ. So you can't translate word to word. So you have to wait a little bit to get enough context and then translate it, and so forth. But there are models in NLP that, try to do this. And I think you can do a lot by kind of doing, predicting kind of essentially what you're going to say. So I think that a lot of this can be done without even, deep understanding of, language. What I think we've learned from translation is that, while translation is getting 90% of the way with translation, doesn't really require any understanding of language. It's just kind of matching kind of symbols contextually. I think getting the remaining bit and having translations that you can actually, trust and are nuanced and proper, I think is going to require, quite a bit of more work. Okay, so another question. Are there examples of building languages with RL? Making it advantageous to communicate in a agent environment, a multi-agent environment. So there is a bunch of work on what is called kind of multi-agent communication, where people set up some sort of environment and let a bunch of RL agents, train a bunch of RL agents to act in this environment, where one of the actions is talk, right? So this is an interesting experiment where you can actually get certain types of languages to kind of evolve from this procedure, and language does help you play the game or solve the environment better. But it's rare that these languages just automatically line up with our notions of natural languages, because often these worlds are too kind of limited for kind of language for it to be necessary to take on that kind of richness. And also, I think just that there's no pressure that these have, the human language is probably not optimal for, for anything. It's just what we have and what we kind of happen to evolve. So, but that's a good question. What are major problems in society that advancing NLP will solve versus what problems it may create? So there are a bunch of places where NLP can be used for societal, good. So one thing that it can do in principle is to allow a broader set of people to, especially with different people who might not speak English, to be able to kind of tap into English resources and breaking down the kind of multilingual barriers. It's also been useful for doing kind of analysis on studying how people talk. So Vandrewski and others have a project on analyzing how language of police officers in stops compares depending on whether they're stopping a black person or a white person. And this could be, and using NLP techniques to try to study that question. So I think one huge area is language is used in a kind of in a social and societal context. And therefore building tools that help us manage and navigate that societal kind of landscape can be really interesting. Problems it can cause, certainly fake generations, biases in models. If we start trusting translations or our systems, it could lead to kind of amplification effects where kind of the haves and the have-nots get kind of pushed farther apart. All right, well, I think we're out of time, so thanks everyone for coming and listening, and have a good rest of the week.